Hello dear friends, Namaskar, chapter number 13 of subject science and topic number 5, that is electromagnetic induction. It was an observation made by the great scientist of electricity, that is the father of electricity, Michael Faraday, that whenever we bring in a magnet towards a coil, then a magnet induces current in the coil. And whenever we bring out a magnet, then again the lamp used to blink, means current used to induce in the coil. But it was not clear about the direction. So Faraday opted for a galvanometer. Now it was very clear that the direction of the induced current while bringing in and bringing out of a magnet, the currents which were induced in the coil during moving in and moving out of an action of a magnet are different in direction. So it is very clear in this figure that when we bring in the magnet, the deflection is like this. When we bring out, the deflection is like this. Means the direction of current in one action and direction of current in another action, they are reverse of each other. They are opposite to each other. Now, what is the galvanometer? The new terminology that we have come across in this topic, right? So galvanometer is a current measuring device basically. It measures the current, the magnitude of the current, but actually it is not utilized for measurement of the current. Actually, ammeters are used for the measurement of the current, but galvanometers are the very primitive devices which are generally used to see the direction of the current which is flowing in the circuit, whether direction is positive or whether the direction is the negative, whether direction in this direction or that direction. So the direction of the current is primarily measured with rather than detected with the help of the galvanometer. So galvanometer is a direction detecting device for the current. Now let us take one more example of the induction. When we switch on the current in coil number 1, it was observed that whenever the current used to pass in the coil number 1, then due to this coil, which coil? Due to the coil number 1, this coil, due to the coil number 1, the magnetism will be produced. Why? Due to the current flowing in the coil number 1. And this magnetism, which has been produced with the help of the current, which has been produced with the help of this battery, this electricity, this electrical energy has produced now magnetism in the coil number 1, and this magnetism will now link with the coil number 2. So the magnetism which has been produced in the coil number 1 due to the electrical energy of this battery will now be linking with the coil number 2, and this magnetism actually which is changing in the nature will produce a current in the coil number 2. This process is known as the electromagnetic induction. So the examples which we have covered in this exercise are related to the electromagnetic induction. What they reflect actually, that whenever there is a change in the magnetism, current is produced. Current is not produced if the magnet is stationary in the nature. Mind well these words. Current is not induced. We will use the word induction. We will use the word induced. Current will not be induced if the magnetism is stationary. If there is no change in the magnetism, there will be no production of the current, right? So Faraday concluded that rate of change of magnetism produces electricity. A rate of change of magnetism produces electricity, right? So if there is a greater change of electricity in the coil 1, there will be greater change in the magnetism of coil 1, and hence there will be greater change in the magnetism that is associated with the coil 2 from coil 1 will be greater, and hence there will be greater amount of the current in which it will be induced, which will be produced in the coil number 2, right? Faraday also concluded that if we increase the number of turns in coil 1 or coil 2, then there will be increase in the production of electricity, there will be increased induction of the current. So what are the observations of Faraday? Faraday concluded that the direction of the current which induces in other coil is dependent upon the direction of the movement of primary coil over a bar magnet or a current changing in the coil number 1. Second observation, rate of change of EMF, rate of change of voltage that induces in coil number 2 is directly proportional to the number of turns of a coil, right? So, what we conclude from this discussion, it is very clear that the potential difference or the voltage which is induced in the coil number 2 whenever the electric current through coil 1 is changing. Now, I think you must be clear about the electromagnetic induction and the word electromagnetic induction. Electricity induces magnetism and magnetism induces electricity once again in another coil through once again the magnetism. Repeat, electromagnetic induction means electricity induces magnetism in coil number 1, then this magnet links with the magnetism of this magnetism linked with the coil number 2 and it generates current in coil number 2. Coil number 1 is called the primary coil and the coil number 2 is called the secondary coil. As the current in the first coil changes, the magnetic field associated with that coil is also changing. Hence, the change in magnetic field lines associated with the secondary coil also changes, which induces the electric current in it. This process, now this is the definition, this process by which a changing magnetic field in a conductor induces current in another conductor is called electromagnetic induction. In very simple word, electromagnetic induction is nothing but the phenomenon of production of electricity or current in another coil due to the change in magnetism in one coil, right? So this induced current is found to be the highest when the direction of the motion of the coil is at right angle to the magnet field. What is that? This was the third observation made by Michael Faraday. What did he say? That there is the induction, there is the generation of electricity in coil number 2 if there is a change in magnetic field in the coil number 1. That was the observation number 1. Observation number 2, the rate of change of the rate of change of magnetism in the coil number 1, if it is higher than the current which induces in the coil number 2 will be higher. If the number of turns are increased, then the amount of current which generates will also be higher due to the higher linking of magnetism. And finally, the direction of the current are also dependent upon the direction of the movement of the magnetism, right? So the induced current is found to be the highest when the direction of the motion of the coil is at the right angle, because if the direction of the movement will be something like this, then there will be no interaction between the two and no current will be produced. But if it is at right angle, maximum linkage will be there, maximum production of the electricity will be there. So these are the observations which were made by Faraday and which has led to the generator principle, which has led to the generator which produces electricity in our real life. The electricity which we are consuming, the electricity by virtue of which you are watching this video are totally generated by generators, and all these generators are based on mostly electromagnetic induction. I hope this concept might have been clear in your mind. For such more videos, stay tuned to Free Education by RK. Thank you.